So this is for linear functionals. So that's one of the conditions that we need for the well-postedness of a weak form like that. The right-hand side, the linear functional, has to be bounded or continuous. If you don't have a continuous, let's say if you have a right-hand side that is even more non-smooth than the delta function, then the Poisson's equation doesn't have to have a solution even in the weak sense. But in this case, because the delta function is a bounded linear functional for H1, and our weak form for Poisson's equation we did last lecture is defining H1. Therefore, we still have a perfectly valid solution, and we can do error analysis and a bunch of things for finite element if we have a Poisson's equation with the delta function being the right-hand side. Is your question if you define L of V as the integral of the function between 0 and 1? What do you mean by a step function between 0 and 2? And you're saying you're going to replace the delta function with a step function? Is that right? So L of V is a function that maps from a linear space, from a functional space, to a field, let's say the field of real numbers. Okay, so the result of the L of V has to be a number. So what do you mean by like L of V is a step function? I can define this. I can replace the delta function by a step function, for example. That'll be a perfectly valid linear function, though. Is that what you? XV? Oh, the example we are taking here is L2 and H1. The L2 space and H1 space. L2 space is all the functions whose square is integrable. H1 is all the functions, is the space of all the functions whose square is integrable and also have square integrable derivatives. All right. Does that answer your question? Oh, okay. I mean, if you still confused, keep asking. Okay. Any other questions? Okay. So this is what we have to have for L of V.